Hello everyone, my name is Antonia Eichelberg and I'm a researcher at EAWAG, and today I will talk in this video about chemical disinfection against Legionella in building plumbing systems. This work was part of work package 8 of the LeCo project, which was about disinfection, mainly chemical disinfection against Legionella. Why do we even talk about disinfection? For this, we need to have a bit of a closer look in a building plumbing system. Here on the left side, you see a very simplified image of such a system. And as you can see, there is a hot water line and a cold water line with very different temperatures. This is important to know that Legionella only grows in a certain range, so in this critical range, meaning from 25 to 45 degrees. And it is important to keep water temperatures outside of this critical range so that Legionella cannot even start to grow. But this is not always possible, as already presented in other videos of this series. There are structural defects or system defects that can be tried to eliminate, but often not always possible. So what do we do if the structural optimizations and temperature adjustments are not possible or just do not work and Legionella contamination comes over and over again? So for this, disinfection is often chosen. There are many different types of disinfection, for example, thermal disinfection or point of use disinfection. In this presentation, I will talk about chemical disinfection methods and how they are embedded in the Swiss legal framework. So, chemical disinfection method. There is mainly shock disinfection and continuous disinfection. The first one is a short-term one-time disinfection with a very high concentration, and the other one is a long-term disinfection with low concentration. Because of these differences, they are also used for different purposes. So one is used for remediation and the other one for prevention. So let's have a deeper look at them. Shock disinfection is a chemical disinfection that is mainly used for remediation. So the aim is to eliminate existing Legionella contamination. So there is a contaminated building and system optimizations or remediation have been tried or have been performed, but the Legionella is still in the biofilm and in the system. So there is a high concentration of chemicals applied to eliminate those. Important to know is that the system is disconnected from the user. That typically high concentration of chlorine, chlorine dioxide, or hydrogen peroxide are applied, and as it is disconnected from the user, and there are no direct regulation on this. However, there are guidelines how to apply this. Important for this shock disinfection method is that the optimal concentration and reaction times are chosen and material compatibility are checked. So every building plumbing system is built up with different materials, and these chemicals do not only react with the biofilm or with the Legionella in the system, but with the whole system, so also with the tubing. So it's important to assess this. Also, it is important to keep in mind that not only the compounds that you use have any health risk or environmental impact, but also their byproducts. So it's important to measure for the compounds, but also for the byproducts, and in the end, to properly dispose them. Very important is that building plumbing systems are very complex systems, and often not all sections are reached. But Legionella can grow in very distal parts of the system, and so it needs to be made sure that with the disinfection or with these chemicals, every single tap is reached. And last point to keep in mind for this method is that after the disinfection method was applied, there's a proper flushing of the system, because the compounds and byproducts can remain and should be flushed out before it is reconnected to a user. So let's look at continuous disinfection. This is a chemical disinfection that is often used for prevention. So the aim is to prevent the colonization and or recolonization of Legionella in the system. This is, for example, used in already remediated buildings that already performed for system optimizations, maybe also a shock disinfection, but the Legionella contamination comes back, or they just want to be sure that it does not come back. Also, for example, in buildings with occupants at high risk, for example, hospital or retirement homes, or in energy-saving buildings. So this is a highly discussed topic, but in this energy-saving buildings, the aim is to save energy, and one part is by reducing or lowering the water temperature of the system, but this can drop then in the Legionella critical range. So to be sure that there is no Legionella growing in the system, other strategy needs to be applied, and often continuous disinfection is chosen. Important here to know that the system is not disconnected from user, then it is a long-term application and the user are exposed to these chemicals. This continuous disinfection is regulated by the TBDV, and the compounds that are used are chlorine, chlorine dioxide and silver ion, and also there are guidelines that describe how to apply. Important is to check the material compatibility because it is a long-term disinfection and these chemicals can cause aging of the system. And also, as before, it is important that it reaches all sections of the building plumbing system at sufficient concentrations so that the whole system is being disinfected. Here we have the comparison of the two, so the remediation, meaning shock disinfection, and prevention, continuous disinfection. Of course, this is a very simplified description of the two, and there are also different situations. The aim is remediation, but the building cannot be disconnected from the user. So it is performed, or there is a continuous disinfection performed. So as mentioned before, for the continuous disinfection, there are regulations. And for the shock disinfections, there are no regulations, but for both, there are guidelines how to apply them. So let's look at continuous disinfections and its concentrations in the context of the Swiss regulations and guidelines. Here you see a table with the different disinfectants that are mainly used. However, as a side note, ozone is also allowed in Switzerland. However, it is often not taken into consideration because it is not considered sensible for use in building plumbing system, as it is very reactive and often does not reach distal parts of the building plumbing system. So let's stick to the concentrations and disinfectants are mainly used. These are chlorine, chlorine dioxide, and silver ionization. In this study, we assessed scientific peer-reviewed literature and created a report to see the effective literature-based and scientific-based concentrations for chemical disinfection against Legionella. So let's look at the effective concentrations. Here you can see the effective concentrations found. You can see that for chlorine, chlorine dioxide, these concentrations are very different. So the maximum concentrations are way lower than the effective concentrations. So this shows that the maximum allowed concentration in Switzerland should be deeper looked at. However, it does not say that the effective concentrations found in the literature are one-to-one applicable. It should be known that these studies are from all over the world and not all systems work the same way. And so these things cannot be applied one-to-one, but it just clearly shows that those maximum concentrations for continuous disinfection should be checked for their effectiveness. Also, it is important to see the disinfection byproducts. As mentioned several times before, there are harmful byproducts that can be formed from this, and they can have health hazards and environmental hazards. So this all needs to be seen in a broader context. Interesting, what also can be seen here is that silver ionization, the allowed maximum concentrations are actually in a concentration range that is higher than the effective concentration, which seems good or seems that this should work. However, most studies describe a combined copper-silver ionization and not silver as a standalone method. So also those values cannot be taken one-to-one, but should be reassessed and looked at. So what did I actually want to talk about? So first of all, chemical disinfection, and that Legionella prevention is important, and if structural optimization and temperature adjustments are not possible or do not work, or there are other reasons, chemical disinfection is taken into consideration. And here, the main thing is to distinguish between shock disinfection and continuous disinfection. As simple as this sounds, there are challenges, and these challenges need to be taken in consideration if such a disinfection method is chosen. So first of all, those chemicals, they do not react only with biofilm and Legionella, but they also react with the whole system, the building plumbing system, and there is corrosion of plumbing. So this needs to be taken into consideration. So a lot of those methods don't act only on the biofilm, but also on the whole system. There is a formation of byproducts. So when we disinfect the system, there is not only one chemical that we give in, but it can also come harmful byproduct. They may be even more harmful than the chemical that we originally put in. Also, there are environmental negative impact that should be taken in consideration, and that the Swiss regulations limit the concentrations of the disinfectant, potentially reducing their effectiveness in certain buildings. And those regulations and restrictions should be closer looked at. So, but mainly important is to know that regular maintenance and water temperature control are essential for Legionella prevention. With this, I would like to end my presentation, and first of all, thank you for listening, and also thank my whole group at EAWAG, Frederick, Alicia, and Marco, and especially would like to thank Frederick that created with me this report that I mentioned. And I, of course, would like to thank the whole LeCo research team. Please, if you have any further questions, please contact me with this email address or follow the link on the main page.